Okay, so in this section, and really in the rest of our chapter here, we're going to be talking about analyzing whether or not a statement, something that I say, is true. So the biggest thing that's going to be, when it's a simple statement, it's not too bad to do. If I say that it's raining outside, it's pretty easy to see, yes, I'm right, or no, I'm wrong. But it gets a lot tougher when you have compound statements with multiple parts to them. You want to say if the whole statement is true or false. So we will be using the concept of a truth table to help us out with this. So a truth table is going to be a table that analyzes the truth value of a compound statement. And by a truth value, I'm going to write this here. Truth value is basically saying, is the statement as a whole true or not true? So a truth table is going to be a very useful way of doing this because it shows you all possible cases. It organizes everything. So it organizes all cases possible. So you can look at it right away and be like, okay, if this part is true and this part isn't, then your statement is true, etc. And this will make a lot more sense as we get into actual examples. So truth tables look similar to this. You have a little box right here, and typically what you have is the letters or the statements that you care about. So here we have P, and then on the, so we have P over here, and on the right side we have the negation of P. Now what we're going to do is actually run through all the different possibilities for P, and we're going to see how that affects not P. So first of all, P could be a true statement, or P could be a false statement. Those are the two possibilities we have. Well, if P is a true statement, that means the opposite of P, not P, is going to be false. If the original is true, that means the negation is false. And if the original is false, the negation is true. That one's not too bad because you're essentially just taking the opposite symbol for that. Now, if we have two statements, it gets slightly more complicated. Not bad at all, but there's a little more to it because we have P and Q right here. And when you have these two, we could have it where both statements are true. P is true and Q is true. These are just two random statements. We could have it where P is true, but Q is actually false. We could have P being false and Q being true. Or we could have a situation where they're both actually false. So these are like the different possibilities we're looking at here. One of those four things has to happen if you get two random statements. So usually in a truth table, you'll start out with a couple things like P, Q. Later on, we're going to add in an R. I will typically fill that part out for you in your truth table because it's the same thing over and over. You will always have those same possibilities where we have both true, true, false, and so on, like that. So typically, I'll just fill that in for you. If you were in a situation where you had to do it yourself, notice on this one, if you look at P, I usually fill these in going down. We have true, true, false, false. And then Q just alternates right here. We have true, false, true, false. So if you had to fill in your own, you could. But like I said, typically I'll give them to you because it does get kind of tedious having to do this part over and over. But we're going to be looking specifically at the truth value of a conjunction on this slide. So we have our conjunction symbol right there. That's our and symbol. Now, in order for a conjunction to be true, let's think about, I'm going to get probably easiest to see through an example. Maybe I'm going to say that I have math homework and I have science homework tonight. So P will be math homework and Q will be science homework. And we want to know if my statement is true or false. Am I being honest? Am I telling the truth? Or am I lying? So if I say I have math and science homework tonight, and let's see, math is true, so I do have math, and I do have science, well, I'm telling the truth. Both of those parts are true. That means my statement P and Q is also true. Now let's say I go home and I say I have math and science homework tonight. I really have math homework, that part's true, but I don't have science. That's false. I'm lying right now. I said math and science. That means I have both. So if Q is false, this whole statement, like the P and Q as a whole, is false. I'm lying if I say that I have both. Similarly, if I don't have math, but I do have science, and I say I have math and science, I'm lying. And finally, if I don't have either, then I'm clearly lying as well. So if I don't have any type of homework, saying I have math and science is just plain wrong. So when you have a conjunction is only true if both parts are true. Like in this line right here, that's the only time we put down true under this column. That's actually worth writing down as notes. So P and Q is true only when P and Q are both true. Or only when you have a situation where it's like true and true. That's the only time you'll say true to a conjunction. Similarly, we have a situation here with a disjunction. Disjunction, there's a symbol for that, those are our or statements. So let's say somebody asked me where my friend went, and I said he went to the movies or to the store. So P in this problem would be movies. So he went to the movies or he went to the store. Q would be store. And that's what I tell my friends. Let's say it's true that he went to the movies, and it's true that he went to the store. Now I say he went to the movies or the store, I'm right. He went to both of those spots, remember, or it can be one or the other. So I am right in this situation. Now let's say he just went to the movies, but he didn't go to the store. But if I said movies or store, he went to the movies, I'm right. That was good. So that's going to be a true statement. Similarly, if he goes to the store but not to the movies, that's also going to be true. The only time I'm wrong, where I'm like lying, is if he didn't go to either one. If I say he went to the movies or the store and he just went to, I don't know, the swimming pool, then I'm wrong. That's a false statement. So when you're dealing with a situation where you have an or, so P or Q like this, it's true when you have at least one T. So if you have T and F, or sorry, T or F, or something like that, that's okay. As long as there's at least one T. Here there was a T, here there was a T, here there was a T. My statement was true. The only time it was false was when I had two falses. And final slide for this video here. We're going to get more into situations where we have three variables, but for right now, I just want to run through how the different possibilities work here. It turns out if you have three statements, there are actually 8 possibilities. So when we're filling this out, all 3 of your statements could be true. That's always the first possibility. It's always possible that all 3 things we start with are going to be true. We could have a situation where we have true, true, but R is really false. We could have true, false, true. We could have true, false, 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 true, true, and so on. I'm just going to basically fill in all the possibilities here, all the different combinations of F and T that you could have in this sort of situation. So, again, with this part of the table, I will certainly be giving this to you guys. It's rather tedious to have to write out every single time. But I do want to point out, if you were to write it out on your own, this one isn't so bad. If you look up and down, we have 4 T's followed by 4 F's. Here we go 2 T's, 2 F's, 2 T's, 2 F's. Here it alternates every other. So it's not too bad to actually fill out yourself, but it's extra tedious since that I generally won't make you guys do it.